Hi guys, I'm back with another video and sorry for being MIA for a long time, but from now I'll try to be more consistent. So today we have another interesting question from arrays. So this question has been asked in Flipkart interviews and also in Google interviews. So let's see what the question says. So the question says that we have been given a sorted array of size n and a number x, and we need to find the number of occurrences of x in that array. Okay, so let's see what is the array example. So we have example as this, and then we have x equals to 2 and n equals to 7, which is the size of the array. And if we see the target element is 2, so we see that the occurrence in that array is 4, so that is why we get the output as 4. Now let's see second example where we have the same array and we get the targeted element as 4, but since we don't have 4 in this array, so the output is 4, right? Now they said the question also says that they expect a time complexity of log of O of log of n, and expected auxiliary space would be of O of 1. So the answer itself is in the question. So they want us to apply binary search here. Now how we can do using binary search? Now for people who don't know what is binary search, so I'll just give a small brief about what is binary search. So for example, we have an array called 1 2 3 4, right? And we'll have two pointers here, start and end, right? So we'll play with the mid element and we'll try to find the target element with mid, meaning our search will stop until we find the mid element is equal to the targeted element. So basically ARR of mid is equal to my target element. So that means I have found the element and my search has to stop, right? So this is the condition for finding the element. Now what is the condition for stopping the looping, meaning when should start and end stop, right? So it should stop when your start is greater than end, so it should not overlap. So it should always be, start should always be less than or equal to the end pointer, right? Now how we will check, right? So how we will find the mid element and evaluate, like manipulate the start and end pointers. Now we have if and if else loop for that. So for example, so I'll show you how we can do that. So for example, here what we will do, like we'll check if ARR of mid, right, is greater than target, then what we need to do, since this is start and this is end, right? So we need to maybe decrease the range of our evaluation of like of the start and end array. We need to decrease the range, right? So now we have 4 elements. Now when we get to know that hey, the ARR of mid element is going greater than the target, so maybe we need to decrease the element, so we'll decrease the end pointer, right? So we'll decrease the size from end pointer, so end would be then mid minus 1, right? Now how we can find mid? First of all, so mid equals to start plus end minus start by 2, right? So what is the mid here? Our mid would be start plus 3 minus 0, which is 0 here, by 2, that is equal to 3 by 2, that is equal to 1.5, right? And we will round it off to 2. So basically this is my mid element, right? Now I said if ARR of mid is greater than target. Now let's say we have a target of 4, right? We give a target of 4 and we have to find the we have to find 4 in this array, right? So is the ARR of mid greater than target? No. So let's go to another condition, asking is ARR of mid less than target? So here we have yes, it's less than target. So basically we'll move the start pointer to mid plus 1, right? So basically if it is less than, right, if it is less than my targeted element, so somewhere it's there in the right hand side, and if it is greater than my targeted element, so maybe it is somewhere in the left hand side of the array, right? Else else if ARR of mid equals to target, then return true, right? Because maybe we have found the element then, right? So let's try to do a small dry run using this only, right? So what
We have 1, 2, 3, 4, right? I have start, I have end, I have mid, right? So my start would be
0 and end would be 3, right? So it would be always the end of the array and start would be always be the first element of the array. Now what would be the mid element here, right? So the formula is s plus end minus start by 2, right? So we'll do math dot floor so that it gives us the rounded off value, right? So what would be mid here? S was start is 0, so 0, so it would be 0 plus 3 minus 0 by 2, right? So that would be 0 plus 1.5, that will round off to 2, so 0 plus 2 equals to 2, so we have mid as 2, right? So this would be mid, and target element is 4, right? Now we will check the condition if ARR of mid is greater than, meaning this is it greater than my target element? So I said no. So is it less than my target element? So I said yes, it's less than 3 is less than 4, right? So I'll just move my start element to mid plus 1, right? Here we discussed, right, that if it is less than target, then my start pointer would move to mid plus 1. So because maybe it is somewhere here in the right hand side, right? So I'll do, what is mid here? 2, and what is start here? So it would be mid plus 1, right? So it would be 3, right? Now I will again find the mid, end is 3, right? Again find the mid. What would be mid here? Start is 3 plus 3, start end is 3 minus start, that is 3 again, by 2, so 3 plus 0, this is 0, right? So we get the mid as 3, right? Now we got this start and end and mid. Now we will check through this loop, that is ARR of mid less than target? No, it's not less than target, because now our mid is 4, right? Is it less than target? No, it's not. Is it equal to target? Yes, it's equal to my target, right? ARR of 3, meaning ARR of mid, right? ARR of mid is equal to my target. So basically I have found my element at position 3, right? So this logic we have to apply to this question, right? Now let's try to do this question here. So it says, what is the array? 1 1 2 2 and 3. I have 2, my target element is 2, right? So if I find the first occurrence and the last occurrence targeted element 2, then maybe I'll find the frequency. Then what would be the frequency? 1. Why? Because this is found at 2 position and this is found at 5 position. So 5 minus 2, that is 3, plus 1 4. So I can find the frequency, then that would be an output, right? So what we can do here, so first we will try to find the first occurrence of 2, and then we'll try to find the last occurrence of 2. So here what we can do, so for first occurrence I'll write code, try to do for first occurrence, okay? So basically when we find the element, right, when target equals to your ARR of mid, we'll take a variable position, right? That would be equal to -1, and we'll just store that position equals to mid. Store the position of the mid element in this pose variable, and then we'll just change the end pointer, right? End pointer would be mid -1, because we have to go to the left hand side, right? Left hand side, like if we find somewhere here, like if we find the targeted element for first position, like we have to find the first occurrence, and we have to search it in the left hand side, right? Left hand side of the mid element. Now for example, if we need to find in the right hand side, so we need, then this condition would not be valid. Then we'll go start equals to mid +1 for last occurrence, right? Because we have to find it in the right hand side of the array, like right hand side of mid element, right? Now let's a pseudocode that we try to give. So same logic we'll try to do using binary search. It's only that we have to change for when we find the element at the mid position. Okay, so let's try to do first position, right? First occurrence, right?
So we have 1, 1, 2, 2 and 3, right? Now I want to find the first occurrence of element of the targeted element, that is 2, right? So I'll just write start, end, mid and position, right?
Now what would be my start? It would be 0, and end would be 0, 1, 2. So n is given 7, right? So it would be 6, right? So my start would be 0, end would be 6. Now we have to find the mid. What is mid? Mid formula is
start plus math.floor end minus start by 2, right? So what is that?
Start 0, end is 6 minus 0. So 6 minus 0 by 2, 6 minus 0 by 2 equals to 3. So it would be 0 plus 3, that is equal to 3. So our mid position would be, let's mark the indexes. So our mid position would be this one, right? So let's try to store it here saying 3, right? Now we will check if it is equal to our targeted element or not. So I say so I'll check if is ARR of mid greater than targeted element? No. Is ARR of mid less than target? No. Is ARR of mid equal to my target? Yes, it is. So my position would be 3. Now remember, I told you that for first occurrence we need to decrease the end pointer. So since we found the element, right, at position 3, I want to find the first occurrence. So we will go here in the left hand side of the mid element. So then my mid element would be mid minus 1. So what is my mid? 3. So it would be mid minus 1, that is equal to 2. Now my start is 0 and my end is 2, right? These are the new start and end pointers. Now let's try to find the mid again. So what is start? 0. What is end minus start? 2 minus 0 by 2. So that would be 0 plus 2 minus 0 by 2, that is 0 plus 1, right? So it would be 1. So this is my mid now. Now I again check, is ARR of mid greater than target? No, it's not greater than my target, right? 1 is not greater than target. Is it less than my target? Yes, it's less than my target. So what I need to do, I then need to increase it, right? So when it is when ARR of mid is greater than target, right? So we need to decrease end pointer, right? Mid minus 1. Now what if it is less than target, which is our current condition? Then we need to increase the start pointer, right? That would be start equals to mid plus 1. So we find that 1 is less than 2. Yes, so I'll just increase my start pointer by mid plus 1. So what is mid? 1. My start would be 2, end is 2, right? Now we'll find the mid again. So what will be my mid? Start is 2 plus 2 is end, 2 minus 2 by 2. So 2 plus 0 basically. So that is 2. So my mid is 2, right? So here we get the mid element, right? So I'll check, is ARR of mid greater than target? No. Less than target? No. Equal to target? Yes. So then what I'll do, I'll just save the position of that mid into my pose, right? So this is 2, right? And then I'll decrease it and decrease the end pointer mid minus 1, right? So this would be 1. Now I'll not able to do further calculation. Why? Remember I told you that the condition should be start is less than or equal to end. But what we find it here, that 1 is less than start. So I'll loop at here and we stop here, and then we find the first occurrence of targeted element, which is 2, right? We get the first occurrence of targeted element, right? Now we will try to find the last occurrence of the targeted element.
Right, so start, end, mid, and pause. Right, so what would be our start?
0, end would be 6, mid would be 3, definitely, right? Now I'll check so here we have different condition when we get to the targeted element, right? So now we need to find targeted element in my right hand side. So I'll just change the start pointer, right? Because I want to go into my right hand side of the mid element. So I say that is ARR of mid equal to target? So I say yes, it's equal to target, right? This is my mid. So I just need to modify my start pointer. That would be mid plus 1. What is my mid? 3. So I'll just change it to from 0 to 4, and then my end would be 6. So yeah, here also position I'll store, right? Yeah, position would be 3 here. Right, now again I'll try to find the mid. Same formula, 4 plus 6 minus 4 by 2, right? So 4 plus 2 by 2, 4 plus 1, right? 5. So my mid is 5. Let's see what is at 5, right? So yeah, we have this 2 at 5 also. So we'll check if is ARR of mid less than target or greater than target. Both are not satisfied. Equal to target? Yes, it's equal to target because it's 2. So we'll just store the position at in pose variable, right? Now remember when we try to find here, so we'll again change the start pointer. That would be mid plus 1. So what is my mid? 5, 6. It will change to 6. Now again I'll try to find the start again I'll try to find my mid, right? 6 plus 6 minus 6 by 2, that would be 6 plus 0, right? And then mid would be 6, right? So is it greater? Yes, it's greater. Then what is my condition? That end equals to mid minus 1, right? So my mid is 5, mid is 6, so end equals to mid minus 1. So we see that it's again like breaking our condition, right? That start should be less than or equal to end. So here start is greater than end, right? So it's basically beyond end now. So we find the final position of the targeted element, the last occurrence of the targeted element as 5. So first occurrence was 2, right? And last occurrence is 5. Now how do we find the frequency? That would be last occurrence minus first occurrence plus 1, right? So 3 plus 1, that is equal to 4. So this is our frequency of this targeted element. Now let's try to do the same thing in using JavaScript, right? And code. So first we'll take first, right, to find the first occurrence. First, then we'll take start, that is equal to 0, and then we'll take end equals to n minus 1, right? and then we'll try to do while start is less than or equal to end. Right, now we'll try to find the mid.
It is start plus math dot floor and we'll do end minus start by 2.
Position. Now we'll add a if else loop. So we'll say if ARR of mid is equal to targeted element, then first should be equal to the mid position, right? And then my end should be mid minus 1, because I'll try to find in the left hand side of the mid element now, right? Else if ARR of mid is greater than x, then what we need to do, it is greater, right? So we'll try to do it in the left half. So my end would be mid minus 1, right? Then another condition, else if ARR of mid, it should be less than x, then my start equals to mid plus 1, right? Now we will try to find the last position. So let's do last equals to minus 1. Similar variables, we'll choose start equals to 0, end equals to n minus 1. Then we'll try to loop through again, start is less than or equal to end, right? And then we'll try to find the mid, const mid equals
to start plus math dot floor end minus start by 2, right?
Then we'll try to find the array, mid element, ARR of mid equals to x. Now we need to find the occurrence of the target element in my right hand side of mid element, right? So what would be our last, that is equal to mid, and then start will be equal to mid plus 1, right? And then else if
same condition, if ARR of mid is greater than x, then maybe I need to decrease it, then start equals to mid minus 1. Else if ARR of mid is less than x, then start equals to mid plus 1,
right? Now I'll simply just try to return it. Now we also had an example where it was not there, like the element was not in the array. So for that we just simply need to check the position of first and last pointer. So we'll just check like return first, right? If return first equals to minus 1 or last equals to minus 1, then we'll just simply return 0, or return us last minus first plus 1, right? So let's try to compile and run and see. Yeah, it is giving us the expected output. Now let's see for other test cases now. Yeah, so all the test cases pass within the required expected time. And also remember, for binary search the time complexity is O of log n. Make sure you press the like button and subscribe to my channel to get more such DSA solutions in JavaScript.